Thank you guys, everyone, for coming. I noticed there's a lot of first-time people out here. I tried to get around to everyone and introduce myself. Some people aren't the first time, and I embarrassed myself. So sorry about that. For those of you who don't know, I'm Brandon. I'm the Vice President of Tokyo Rust, and thank you, everyone, for coming. Really appreciate it. And thank you for Google for Startups for hosting us today. It's really great. Let's go. So before we get to the talk, there's just a couple of community announcements and things that I'd like to share with you. The first one is, and hopefully this is the last time, last October, Orhun from Ratatouille, the maintainer of Ratatouille, came out to Tokyo and gave a talk, and we did a little competition, and we had 3 winners, and I'm pretty sure Colin is here today, and I actually, there we go, can give you your ESP32 that he won by making a really cool BPM counter. If you haven't seen that talk, it's really interesting, and it's on our YouTube channel, which is linked on our website, which is tokyorust.org. Whoop, it's a little loud. Okay, the next thing is, I won't announce the title yet, but our next talk is going to be here in about a month, and Alex, who's here today, is going to be giving a talk, and I won't spoil anything. I'll send out the guild and everything, and you'll see it. It's very interesting, and it has to do with Rust, so. So just some community highlights as well. This is something new that we're going to start maybe trying to do. And I did one that I knew about, which is Ross, who gave our previous talk, just started a little project, and he shared some little Hello World footage and stuff on our Discord, which also is linked on our website if you haven't joined. And he's building something so that we can record our slides in sync with our presentation so that we can easily compose them into the video, which making it easier to see. Because right now we just have recordings directly, and sometimes text gets washed out and things like this. So we're moving up in the world. Thank you, Ross, for starting that project. Do you want to share any progress?
Well, I've successfully ran Hello World, and that is about the extent of it. But if you're interested in like helping me, because I don't really know what I'm doing, this is like mostly a learning experience for me, for fun. I'm sure you could buy something for this like on Amazon, but that would be no fun. So if you're interested in helping or or teaching me, please reach out in the Discord or come talk to me, because yeah, that's it.
Thank you, Ross. Yeah, so, and well, there's a second bullet point for you. So we just received relatively recently, and we didn't announce it at our last meetup, that Rustjobs.dev generously gave us a donation. And we showcased them on our website, but I haven't mentioned it in a talk yet. So I'm mentioning it now. If you're looking for Rust jobs, they list them all over the world, and they are free for you to look for a job. And if you want to post jobs, then that requires paying them, I believe. That's their model. So please, if you're looking for a Rust job, check them out. And thank you, Rustjobs.dev, for sending us a donation. And then there's a second bullet point for you, because we take donations. Right now, only within Japan is easiest. We have a link that you can email us to ask to donate, and we'll give you our bank information. Hopefully soon we'll sort out Stripe, and it'll be easier if you are willing to donate. No requirement, of course, so please feel no pressure. Yeah, the last thing is, just as always, we have quite a few talks lined up. We're going to be giving talks at least once a month for the next 6 months, I think, are already booked. But maybe we'll increase the frequency, or maybe we'll do lightning talk section, or whatever. So if anyone's interested in talking about what they've been working on, or something they'd like to work on, or something interesting they heard or learned recently, please send us an email, contact@tokyorust.org, and please be able to give a talk. It'd be great. I already mentioned sponsoring. If your company would like to donate, or you would like to donate personally, that would really help us out. So we could do, I don't know, champagne instead of beer. And the last thing, we've been looking for a little while for an online community lead. And what we mean by that is, right now, Máté and I, and with a little help from Elon and a few others, We bounce like the video files back and forth, and we edit them and we post them on our YouTube. And we don't have like anyone who's really dedicated to doing this. So any marketing events or guild events or all this is just us doing it. And we think if anyone would like to volunteer that's passionate about that, about building a YouTube channel or a community online, we would love your help. And in particular, we could talk details about it privately, but you know, we'll figure it out. And if there's like any way we could help you out, it'd be good. And that's basically it for the community announcements. So today's event. So today's speaker is our very own Máté Kovács. I hope I said it right after all this time. Máté has lived here in Tokyo for 7 years now and is an independent software consultant and the president of Rust.org. So I'm just pretending to be president. I'm just the vice president, but Máté does all the actual work. I helped get this space and with help from Elon as well. So thank you, Elon. Where are you? Oh, there you are. Elon helps us out a lot. He's the actual vice president. I just somehow got the title. And a special thanks to Sunshine, who is the coordinator of this Google for Startup space, for helping us get situated and booking it out. And also I just met, sorry, the name escapes me, but this wonderful man here has been helping us today, these two. Thank you guys for that. So really quick, I think this is the last slide. Yeah. Would you like to introduce your own talk? I'll ask you questions at the end. You want me to? Go right into it. Oh yeah? Okay, so just to give you a little tidbit, Máté is going to be talking about contract-based computing or like requirements and verification and these kinds of things. So he's developed a library relatively recently, which I'm recently actually a contributor to. I landed 1 pull request. So I could say I'm a contributor. And it's called Anodized. So Máté is going to be talking about that and how you can benefit from having more specification than just what the type system can allow you to do. So Anodized gives you the power to do more of that either at runtime or potentially at compile time as well, using some very interesting tools, which I'm sure you'll discuss. And without further ado, here's Máté. I'll ask you more questions at the end.
Thank you, Brandon. I hope this is going to work. All right. You'll understand why we're in VS Code in a minute, I promise. Just note that this is the first time I publicly talk about this library, Anodized. So there are a lot of rough edges. It's definitely work in progress, but people have already been helping out. Brandon, Luke, another friend of mine who's not here. I intend this session to be like fully interactive. So if you have questions, please feel free to stop me. We have microphones that we can hand out so you can ask questions. Yeah, let's get started. We don't have a lot of time. There's a lot of ground to cover. So the overview, and if you fall asleep after this slide, I think I've already achieved my goals if you just remember what's on this slide. So I believe that AI makes software quality more important than ever for a lot of different reasons. And Anodized is a system that helps improve software quality. That's the main goal. It helps both people and machines work better with code, but it is not an N+1 type of thing where it's just another standard, just another system. It's designed from the ground up to integrate with the existing tools, as you'll see. And the main goal of Anodized is to increase adoption of advanced quality, code quality aids, code quality tools. It's a non-trivial task. The main contribution of Anodized is it already works. It works on stable Rust, vanilla Rust that's not extended in any way. So if you know Rust and you're okay with using stable Rust, just try it out today. I'm gonna jump right into it. But first, I want to tell you a joke. A product manager buys a magic lamp off the dark web. A genie pops out and says, "For freeing me, I grant you 3 wishes." The product manager is a great person, So after some deliberation, they think, first, I'll make the world a better place. And they say, math is so complicated. Let's just remove it. The genie says, in progress, done. Great. Now give me $1 million. Can anybody guess what's happened next? That's right. What's $1 million? Just remember the joke. It will make sense. People love talking about how English is the new code. But the reality is that in complex domains, we humans need formal languages for precisions. Mathematicians, programmers, physicists, they're all capable of speaking English, most of them, but they decide to use formal languages to communicate with each other and to be precise about ideas. And I think this is an important fact to reflect on, because there's a lot of talk about how AI enables everybody to code just using English. And I believe that's kind of a fundamental misunderstanding of what programming is. Programming is not about the code. Programming is about figuring out what needs to be done and how, and communicating that intent precisely. The more powerful our machines get, the more important it is that we're precise about what we want. Because if we're not precise, then the fallout might be bigger and bigger and bigger. All right. You've probably also heard this a lot, that programmers are cooked. Are we cooked? Let's see a show of hands. How many of us feel that we're cooked? It is pretty hot, but I don't think we're cooked. Okay, who thinks that we're not cooked? Okay, great. So there's some hope left. And I believe that to stay relevant, we basically need to become product engineers. What I mean by that is we need to develop the skill set of a product manager and a software engineer all rolled up into one. And I think we actually have an advantage. We as in software people, this is a smaller change for us than it is for product people. But from a higher perspective, the problem is the same for both software people and product people, which is the quality control of code. And I believe this is an area where software engineers kind of have a disadvantage. Product managers who don't code, they spent their entire career in a world where they can't precisely control what code is written. They have to control it by precisely specifying and figuring out what needs to happen. But as you'll see, I really believe that the new code is not English, it is specifications. And if you want those specifications to be precise, they will be written in pretty much the same way as programs are. So software people have an advantage there. And this is the perfect segue. The goal, this is the holy grail of software engineering, is to have defect-free, not only Rust, but defect-free software in general. Now, a lot of people are working on this. So the Rust team is working on adding Rust native specifications. These are called contracts, not to be confused with smart contracts. This is in progress. There's a tracking issue that you can check out. It's been open for a long time, and work is kind of slow, but experimental contracts syntax is already in unstable Rust, so you can try it out. I tried it out, and some things that I want them to do, they don't at this point. There are two chains like Ferrocene. Ferrocene is a qualified Rust compiler. Probably if you work in automotive or robotics, should make you very excited. There are frameworks for robotics, specifically like Copper. There are other tools for fuzzing, like prop test, quick check. And there are also verification tools like Anius, Flux, Connie, Miri, Prusty, Varus, and so on and so forth. There are too many of them to even list. This is probably the category where Anodized fits the most. but it's actually a little different, as you'll see. So now you're thinking, the promise of this talk was that we're going to talk about types. Or like, Máté, where are the types? Have you seen this one? It's a tweet by Greg Brockman, one of the founders of OpenAI. He says, Rust is a perfect language for agents, given that if it compiles, it's correct. I wish I could pronounce the tilde in there. Let's see, another show of hands. How many people here feel like this is a true statement? If you think this is a true statement, raise your hand. All right, very confident there. I like it. How many of us feel that this is just not really? Yeah, I think this is mostly hype at the moment, but it's the right kind of hype. Like, we want this to be true. Like, this is the dream, but we're not there yet. So we kind of have to be honest. And this is where prop testing and verification come into the picture. So let's play a game. I'm the product engineer, and you all are the genie, all right? And I have a wish in mind. I'm going to give you some hints. And you need to figure out what this function needs to be. That's my wish, is for you to replace that to-do with useful code that does what I want. Anybody wants to guess? Please raise your hand if you have a guess, and Brandon will bring you the mic.
Index of item in the sequence.
Index of, it's close, but it's not quite.
Anyone else? Remy. Remy's going to one-shot it. Not even going to need anodized.
The number of elements that are the same as the item in the sequence.
That's another good one. It's also not correct. Let me also say that the previous one was closer. So you said index of, right? But let me ask you another question. Look at this. This is just use size, right? So what happens in your case if it was in fact index of? What would happen if the item is not in the sequence?
Yeah, we would have to return option then.
That's right. So we know that this function can't be that, because it does not return an optional.
So it's like an insert position in a sorted list.
Yes, you're right on the money. How did you guess?
From the previous hint.
Okay, you should definitely consider being a genie. Let's just forget about that and continue. That's a great guess. I did not expect anybody to guess so fast. Okay, so I can elaborate on the type signature a little bit. Let's say I add these changes on. I can still use this on ints, right? But now it gives you some more information that the property somehow has to do with ordering. All right. So we're on hint number 3. If you can read English, this should totally give it away, right? Like this is what Anton was saying, that we need to find the index at which inserting this item would keep the sequence sorted. There is a lot to improve here. The main problem is natural language is kind of imprecise. So there's still questions around, like, okay, how do we deal with equal elements, for example? It's all disconnected from the code. So this can get messed up, or this function signature can change without updating this comment. and everything is just disconnected. And the other big problem, which is more of a problem if you're using some sort of AI-based generation tool, which will surely eat this and just give you code, that there's no way to automatically enforce this. Nobody can check for you, especially if you're more like a product manager type of person who doesn't have a lot of experience programming. You just don't know. The genie gave you code, and you just have to trust it at face value. And we can do a lot better than that. So I believe what a lot of you are thinking, actually, let's see. Are there any ideas? Like, how can we do better than this? Than just a comment. And again, stable Rust, no magic, nothing. How can we better communicate the intent?
Write a test.
Write a test. Very good. The reason I'm not going to do that is we potentially would have to write an infinite number of tests, unless we have something like human intelligence in the loop, or the genie is smart enough to sort of extrapolate. Good call that there should be a slide in here. Anything else?
Wait, what? I'm sorry, the recording couldn't hear you.
Property-based test.
Property-based test. What do you mean by that? Can you elaborate to those people who are not familiar with property-based testing?
It will verify the behavior by randomized parameters. Yeah.
Randomizing inputs and then what?
Randomizing inputs, basically, and validate the output.
So we can kind of think of that as driving this function with random inputs and just kind of putting an assertion somewhere, asserting that some property is true, which in this case, hopefully would translate to what this comment means. Okay?
So maybe you write it in a type which is guaranteeing construction to be always ordered.
Write it in types.
Wrap.
If you know how to write that in Rust, I'm super interested.
I think you should add an assertion, possibly a debug assertion, that checks that the sequence is sorted in the first place.
I think that's a great idea. Let's do that. Something like this. All right. So, come again. Oh. So in the beginning, we're going to check that the sequence is sorted. And I could have written this in a, whoops, did not mean to do that. There's surely a less terse and more understandable way of writing this. I just don't have a lot of room on this slide. So sorry about that. But basically what this is doing is it's looking at all the pairs that are next to each other. And then it's saying the first one cannot be greater than the second one. And this must be true for all such consecutive pairs. All right, so far so good. And then what else do we want to do? Well, we also care about what the function has to do once that is true. So we're gonna, the magic happens here. We still don't know what that is. It's up to the genie. But once the genie gives us the output, we first want to say that the output is between 0 and the length of the sequence. And the reason why we allow it to be equal, even though it's supposed to be an index, is because we need to be able, like the function needs to be able to communicate when we need to insert it at the end. So like we need to basically push it when it's larger than all the items in the sequence, then it needs to go at the end, right? So we need to allow this case. That's why this is equality. And then we also need to confirm that if we were to insert this, then the sequence would remain sorted. And one nifty way of expressing that is if we enumerate all the elements in there with their indices. If the index is smaller than this insertion index, then that element itself has to be smaller than the item. Otherwise, the element has to be no smaller, so at least equal or greater to the item. And once these two assertions are true, we know that this function is in fact doing what we want. So we just return this. As you can see, this is kind of messy. It would be nice not to have to write this. Any ideas what we can do there?
We can unify checks. So we will have precondition, postcondition, and invariant.
So any ideas how we might do that in Rust? Maybe you know a library that does that?
Procedural macros.
Okay. Proc macros. I like that idea. I think it's very workable. So this is, in fact, the direction we're going here. Okay, so we can do this. This is coming from Anodized. This is the main user interface. It's called the spec, short for specification. And it has clauses like this, like requires that encapsulate the precondition or preconditions. So we could have also written this as a list like this, and it would mean the same thing. And enumerates the post conditions that must be true once the function has done its job. And you can put comments on them if you like. I think this is kind of nice to have all of this in a single place. It has IDE integration because Rust Analyzer is very smart. So we can fold this away. As you can see, we're getting type information for all these things. If I purposefully try to mess it up, like I say, okay, let's put 45 there. It's going to tell me, you told me this was going to be a reference to a T, and this is I32. So this is a step in the right direction compared to just comments, because this is now integrated with the code. If I start changing stuff, like all I need to do is I need to rename something to blah. And now it's going to tell me, oh, this, I don't know what that means. All right. Okay, we're not going to dwell on this now. But the next thing we're going to do is this is the little demo. We're just going to copy all this code. You see, we've removed all the internal comments from in here. The function is just called mystery function, so there's absolutely no clue what this is supposed to do. We're going to copy this code fragment. We're going to go over and ask the genie what the genie thinks about this. All right.
Man,
this is nerve-wracking. Okay. It looked like it did something meaningful. We can copy this back in here. And let's see if it at least type checks. Okay, that's at least type correct. I have no idea if it's correct, but one nice thing about Anodized, as you'll see, is if all you do now is you write some sort of property-based test that just feeds random inputs into this function, it will catch the invalid implementations just by doing that. All right. Where were we? All right, so why am I working on Anodized? There are so many excellent verification tools for Rust already. I tried a couple of them. I really like one. I like it so much that I'm actually contributing to it. But I think all of these verification tools have a big problem to solve, which is low adoption in general. And my core hypothesis with Anodized is that this is a UX problem at its core. So it doesn't really have to do with verification itself. It has to do with how it's exposed, how the functionality is exposed to end users. And one point I want to really hammer home is that Anodized is not about runtime checks, even though that's how we arrived at this idea. They work out of the box. That's the minimum that you get. But the end game of Anodized is to help other verification tools gain more adoption by acting as a common front end and allowing people to just write standard Rust, not some strange dialect. So these are the problems that you can see on existing verification tools. From an end user perspective, you have to choose a system upfront, and it's often difficult to make an informed decision. You have to kind of learn about all these different systems, understand their capabilities, figure out how they relate to the problem that you're solving, and then you're basically investing a lot because they all use some extended dialect of Rust, and they extend Rust in different ways. So it means if you made a choice that was not optimal in the beginning and you wrote your program, you put specifications everywhere, and you decide you need to migrate to a different system, you potentially have to rewrite all your specs. I would say that's actually the common case. They're basically all incompatible with each other. And that's just difficult. It shouldn't be this way. And from a tool developer perspective, and I've seen this firsthand, designing what these Rust extensions should look like is a difficult problem. It's a completely different type of problem than what verification people are used to. Verification people are usually highly skilled at mathematics, formal logic, understanding these proof systems. And I think it would be way better if they could just focus on that, and they would not have to deal with this UX problem, figuring out how to expose all this functionality. Another problem that they have is they have to integrate their tool with Rust in some way, which means they sometimes have to fork rustc itself or just fork the sync rate so they can parse this extended dialect of Rust. Sometimes they have to fork cargo and Rust analyzer if they want to provide an IDE experience, an integrated experience for this dialect of Rust that they've created. And this is just a lot of work. Rust analyzer is a huge code base. It's very complex. It has some JavaScript parts that I believe most TypeScript, that I believe most Rust people would like to just avoid. So because of this, what Anodized is trying to do is first to work on stable Rust, but with maximum ergonomics. And this is towards end users. And towards tool developers, Anodized wants to provide an integration API that allows other tools to consume these specifications that are already in place. And once they integrate with the specifications that Anodized provides, they kind of become agnostic of the front end. So people can annotate their program with specs, and they can switch between backends that support Anodized. To be clear, tools can still have differing capabilities. So one tool can say, like, this is a type of spec that I can't process, and then maybe you need to change it. But it's not a different dialect of Rust, even when you need to do that. It's just standard Rust. All right, and as I said, this is a working in progress. Please try it out, give us feedback. Big thanks to contributors again, Brandon, Luke, and Maurice is a friend of mine. Unfortunately, he's not here. All right, so now to a tour of Anodized. I find that writing specs, even though it is programming, It's very different, and it feels strange at first that you're not really touching the implementation. You're trying to describe what you want the Genie to give you. So I prepared a few examples to get started, and please feel free to stop me at any point if you have questions. Just let me know if I can clarify things. So here's a simple one. Actually, let's start here, how to use it. So you just put anodized in your dependencies like this, and it forces you to pick a runtime feature. We're using check and panic now, which means at every violation of a spec, it will basically panic. If you don't want that, we have other options available. So for example, you can say check and print, and it will only print but not cause a panic. You can also completely remove this stuff. So you can say no check. Even when you have it in no check mode, you still get this deep integration. So we're in no check mode now. But if I go back to my examples, as you'll see, it's still giving me the help. Whoops. Maybe I broke it. Okay. I actually had a regression before with the Rust analyzer change. So let's just go back to, whoops, check and print. I wonder if that will improve things. Yeah, okay. I have no idea why this is happening, but I'll figure it out. So this function is intended to compute the percentage. You feed it to floats, the part, the whole, and it gives you a U8 that's supposed to be between 0 and 100. The reason I don't have 0 in here is because it's guaranteed to be non-negative. It's unsigned. We could put that in here, by the way. Maybe it's going to make things more clear. Let's do that. I cannot type with one hand. All right. It doesn't do anything, but it's nice to see it. It's probably telling me you don't need this. Yeah. That's very smart. Okay, so things to note here. In the requires clauses, all of these things are just naked expressions. There's no way for them to talk about the output. In the ensures, these are actually closures in disguise. So I could have written this explicitly like this. And it means the same thing. It's actually not having this as shorthand. So as you can see, the parameter that this closure receives is a reference to the output of the function. So the ensures clauses can talk about it. They can say things, this must be true. It must be a reference because this value is going to be returned from the function. So whatever you write here, it cannot consume that value. There will be nothing to return. This is sometimes awkward. You have to dereference it, but so it is. This is standard Rust. There's no way to say this in here. This is semantically wrong. It doesn't mean anything because the requires clauses are checked before the function does anything. There's no output yet, right? Does that make sense so far? Sounds like there's a question in the back.
What would happen if you tried to get a property from the input and be able to use it in the output but the property is only derived. It's not the actual input itself. The input may actually have been consumed.
Can you give an example?
Maybe you would want to derive that the one of your input vectors has like a length, and then the output is some calculated value based off of the length, but the vector is actually being used for some other piece of something like that. It's just
That's a great question. We're gonna get to that in a minute. If we're ready to move on. Any other questions about this? All right, moving on. Okay, so this next function is very exciting. We're going to sort a slice that has exactly 2 ints in it. So we need to communicate that on the output, the first item in the slice has to be not greater than the second one. And then what's this other thing? Why do we need this? Does anybody see why this is here? What kind of wrong implementation can I write here that if this is not here, it's going to allow that? I could do this. Something like that, right? So then the output has nothing to do with the input. So the spec needs to say that, by the way, the output should contain elements that are present in the input. Another way of saying that is it's either the same as the input or it's the input with the elements swapped. It's pretty straightforward. Okay. So now we're going to get to Remy's question. Because what if we wanted to do this in place? Then now we have to talk about what items, the value of items used to be on entry in the insurer's clause. So we can express the same thing. So even though the original value of items is kind of consumed, we make a copy here. So this is what the captures expressions are for. There's a shorthand here, by the way. So it's if you just want to capture items, you can just say this, and it will automatically introduce the name old_items. But if you want to use any more complex expressions, then we enforce that you have to give a name explicitly with as, and then the identifier. Currently, this has to be just a simple identifier. Sometimes it would be useful to make this be a pattern. We have an issue for that. So does this answer your question? All right. Gonna move on. How much more time do we have?
Like an hour.
Okay. I'm not going to take another hour. Don't worry.
When would it be useful to have the pattern match? Like, can you give an example?
So actually, the previous one, we could have written this easier if we could write this.
I see.
Something like this, right? Except it must be a simple identifier. But soon enough, you will be able to write this. All right. Any other questions? Okay, we're slowly building up to a crescendo here. We're no longer sorting a slice that just has 2 elements in it as arbitrary length. So we've seen this guy before. It's making a comeback from earlier. It just expresses that the output is sorted. Again, by saying that all consecutive pairs have to be sorted individually. And now what used to say that the output has to consist of the same elements that the input uses, it's a little more difficult to express. And we have to use this multi-set thing, which unfortunately is not provided by the standard library. So we have a hand-rolled version of this in here, and it's a little messy, but it's doing exactly what you think it is doing. It's wrapping a normal hash map. So once we have that in place, we implement this from iterator trait for it. We can just directly feed in the output by reference. It's going to build the multi-set, and we're going to check that that is the same as the input. So far, so good. Any questions? All right. What should we do next? Any ideas?
What happens if you have like mutable variables that shouldn't change or some side effects that should or shouldn't happen? Like, can't you break everything by changing some global state?
That's a good question. I don't know. We should eventually have a way of expressing that. It's a little difficult in a proc macro. So as you can imagine, all that this proc macro can do and the world that it has access to is just constrained to this one item, just the signature and the body of the function.
I guess I mean, like, if you have an input that's like a composite structure and you know that one subfield should change and others shouldn't, can we do something about that?
You can probably already express it by if the fields are clonable, you can capture them, and then you can do a comparison at the end. So one thing I forgot to mention, but it's kind of important, is because this is standard Rust, anything that you want to capture needs to be at least clone. And if it is copy, then it's less annoying. So if the thing that you're intending to capture, if it is copy, then you don't even have to write the clone there. Here we do because it's a vec. Sorry, slice. There's a question over there.
Is it implied that it won't panic by the ensures?
Does it imply that it won't panic?
Yes.
In fact, it will panic if the ensures condition is violated.
I mean, as part of the implementation, let's say, it panics. I guess that, yeah.
It depends on the runtime setting. I believe, so right now, actually, I'm wrong. Right now, we're in the mode where it will just print that there was a spec violation detected, and it's not going to do anything else.
Yes. Sorry, what I mean is the return type of this sort function is, let's say, a sorted slice or sorted vector. Nothing in the return type says that it will or won't panic. So does the ensures clause, ignoring the checking of the property, imply that the function won't panic? Does that make sense?
That's a good question. I think we probably, Anodized would need some other primitive to express that. Like it could have something like panics false or something like that.
Right. Okay.
Right?
Yeah.
Good question.
Okay.
We don't have that at the moment.
Sorry, just a PSA. Iterator.isSorted exists.
Oh, that's good to know.
Yeah. Is that, can I do in the async function?
Yes.
Yeah. Thank you.
I haven't actually tried using this on async function, but I have tests for it.
Does it work for opaque types on the return value? So for example, if it's using the implement trait syntax, and what I want to ensure is relying on certain fields of the concrete types. Is it able to achieve that?
I'm not sure. That's a good question. In general, whatever you would be able to write as an assertion inside the function body, you can also do with this.
I've had a strange case of coworkers trying to inline code manually using macros. Is it foreseen to somehow have this work on blocks rather than just functions?
That's a good question. The one specific use case I thought of, because it's interesting for verification, is loops, where you generally want at least a loop invariant on a loop. Other blocks, I'm not sure, but it's fully valid question. If you have a use case, I would love to know about it.
英語の自信がない方がいても、日本語でも聞いて、私通訳してあげますので、ぜひ日本語でも聞いて構いませんから、はい。
So will the macro work the same on a like struct method, for example, and handle self just fine?
Good question. The only thing we support at the moment are functions, methods inside of an implementation. And we also have some limited support for traits. So you can attach specs to methods inside of a trait. And it forces implementors to also have the checks. It's not in the version that I'm showing, by the way, because we merged it like 2 days ago. And we do have plans to add more. So it's a good question. We do intend to have specs on data types, not just structs, but enums as well, at least with maintains clauses that would express invariants that the valid instances of the data type must always fulfill. And we also have plans to put such maintains specifications on traits. So like top level, something that must always be true of anything that implements that trait. And then in the end, also about entire modules, where putting specs on the module would allow you to express properties that involve multiple items inside the module. So you could express algebraic properties, like, I don't know, you want to say that some two operations, one binary operation distributes over the other one, like addition distributes over multiplication, something like that.
Thank you.
Just curious, can you show what this expands to?
Yeah, it's very nasty. I'm glad you asked. There you go. I was just on the wrong place.
So if you want to troll this library, name your local's anodized output with 2 underscores before it.
This is less interesting. Let me do the same thing on the percent computation example, because that has both requires and ensures clauses, so it's more interesting. So these are all checking preconditions, right? That the whole is larger than 0, so on and so forth. And because we are in check and print mode, not check and panic, we only print, we print, don't do any panics in here. And then here we run the original body of the function inside of a closure. This is important because if there are any return statements in the function body, if you didn't wrap all of that stuff into a closure, it would break out and prevent from the precondition checks from running. So it's all these little details that kind of get you if you're not careful. And then we assign the output of that to this underscore anodized output internal variable, which we're going to be using so we can return that value. But before we do that, we need to check all the post conditions, where, as I was mentioning, the post conditions are basically closures in disguise, like this, that will consume the reference to this intermediate output value and print useful messages if they fail. Any questions about this? Lots of questions.
Let's go from here.
Is there a way to make it behave differently in tests and production code?
Yes, great question. So one thing we can do is, let's say, I kind of need to close this now. So I could say this. Now this entire clause will only be checked if you're in test mode. I forgot what you have to write here, but you can basically also completely disable them by putting a condition here that will never be true.
I guess what I meant was, like, can you make it panic in tests and like only print in production?
Can you make it panic in tests? We don't have that at the moment, but it's definitely possible.
Thanks.
It's a good question. So to clarify, what you would want is for it to only print stuff in production runs and panic when you're in testing mode, right? Yeah.
You can just run your tests with the feature flag set one way and then create your binary with the feature flags set the other way. So,
hey, that makes sense.
Do you test the anodized itself with these checks and how ugly the code becomes?
Not yet, but there are, so a little bit more about the structure of anodized. At the moment is two separate crates. This thing that we're looking at is the anodized, is the proc macro crate, and its only responsibility is to provide this proc macro. And everything else, all the parsing and instrumentation, is implemented in another crate called anodized core, so that it is reusable by external tools. So if you want to make your own tool that consumes these specifications somehow, and you want to piggyback on the existing instrumentations and add some of your own or change them in some way, you can just depend on anodized core directly. And because the proc macro uses the same parsing machinery, it's actually guaranteed that your tool will see the specs the same way that the front-end anodized proc macro does.
I would say one suggestion, like when you say print, maybe people want to see the whole input, not just one input that fails. Maybe you can include it, and it will be more valuable.
It's a great idea. I guess you would be able to always print debug input for things that implement debug. The problem is some types don't implement debug, so there's no way to reliably print everything. But I guess we could introduce something that says, oh, if this type is debugged, then print it.
I have a question and an observation. So first, I think the idea of using expression. Hello, 1, 2, 3. Yes. Okay, yeah, I have a question and an observation. My observation is going to go first. So I think using expressions is really cool because in theory, other DSLs could be created using other proc macros and compose into this system. So for example, you might be in an industry where you have like a domain specific language, you could write your own crate and integrate it into this, which I think is really cool. So that's my observation. And then my question is, you mentioned using pattern matching for requires, but is there a way that we could maybe do it for ensures as well? So for example, like I have a function that returns an option, and maybe I want to ensure something only when it's sum, right? Is there like, because you could probably do that with like the closure, right? You could just do like if let sum, but that's a bit ugly. Is there some syntactic sugar we could do?
It's a good question. I thought about it, and the reason the case where I had to think about this is we actually, Anodized supports patterns for binding the return value. Let me see if I can find an example of this. Not this one. The other one. Here we go. So in here, we could have written right? We know it returns a slice that has exactly 2 elements. So we can safely write this. And now we can say that. And I wondered whether we should allow irrefutable patterns here, which I believe is what you're asking, like one case of an enum, one variant of an enum or something like that. I decided against it because closures themselves don't allow that. So it would break the simplicity of just saying all of these ensures expressions are basically closures under the hood. So I actually had a feature branch where I tried it out, where instead of this closure syntax, it looked like this. So it really looked like a match arm, and then you could write refutable patterns. And that was kind of a mess, to be honest. It's mostly what makes it kind of messy is on the consumption side, which I haven't shown yet. But if you look at Anodized core, we expose a spec data structure that has all of these things. And there, it's nice to be able to say every ensures expression is just a normal closure expression from sin. Well, people know how to manipulate that. If you start building your own stuff, then it might be a little confusing. But I think it's not like a done deal of which one it should be. There's potential for supporting both of these.
Oh, makes sense.
Good question.
I'll make a comment about the pattern matching as well. As like if you actually go to the next line and you put the same closure pattern, you can actually use the @ to get the output as a whole and also project the elements.
This one where we're doing it in place?
You could do it. Yes, you could do it here. So you could.
Let's try.
So let's see. So it'd be. Well, you already have it. Well, actually, it's easier at the first with the one you had before because it's
this
so
one
on line 7. If you did what you did on line 6, so you put the same AB.
Okay,
like
I'll show you another trick. So there's a shorthand for this, where you can say binds and the pattern, or just rename the output. And now all of these have that default binding. Okay, so what do we write here?
Oh, but you can actually have both. Is what I'm saying. Is you can actually, if you put the closure like you would have normally.
So put output here or the other way around?
Yeah, but I was going to say you could do that with the closure itself. But yes, and then that would actually give you. Normally, you have to put output on the other side, though. But yeah.
All right, let's go back to closure syntax instead of the sugar.
And you put output on the left-hand side, of course, because it's the identifier.
What? Oh, okay. And then what do we want to write here?
Well, before you used output and also the elements, the part you cut out. So it was output is either equal to input or output, or input is equal to the array A, B, right? Yeah.
We're missing some reference stuff here.
Yeah, you could change that in the pattern. You'd probably have to. Yeah, because the problem here is that A and B have become references.
Mm-hmm.
Yeah.
Well, it's gonna be ugly, but it's gonna work.
Yeah. We're gonna get there.
Just dereference everywhere, right? Like
Yeah.
that's the solution.
But my actual
Okay.
question was about earlier you had the CFG on an insurers, and I was wondering if it's possible to have multiple insurers, but with different CFGs and that they union together. Does that make sense?
Hey, that kind of works. Yes. So you're asking whether we can. Whoops. So you can do this, and the purpose of this is exactly as you're saying. Now you can put different CFG things. So you can say like this expensive, sorry, quote unquote expensive check. We only want to do in test, something like that. Yeah, that definitely. I mean, if this is sorting a arbitrary length array, you probably don't want to do this expensive check everywhere. Good question. Also, thanks for the tip. I didn't realize that. Yeah, this is it's nice.
Although Rust Analyzer doesn't seem to like it. It's lying. Report a bug. Let's move on for now, just to make sure we have enough time. And
yes, all right.
if you have more questions, don't worry, we'll get to them. But
right. I think we got to the end. Actually, there's nothing else that I didn't show you. So, thank you for listening. Please try it out. Okay, I guess I'll just mention that, but you can go on and read the README. It's pretty detailed. There's a third type of clause called maintains, which is just a shorthand for writing a condition that is both requires and an ensures. So you don't have to like repeat yourself. I think I didn't miss anything else, right? Yep, that's it. Thanks.
Well, I actually have some questions for you.
All right, go right ahead.
So if you have more questions about the talk, we'll get back to it, but I want to just make sure before we get kicked out that I am able to ask the kinds of questions that we always ask our speakers, even when you're usually the one asking them. But the first one I'll ask is, how did you find yourself in Tokyo? I know that you used to live in the Bay Area and then you found yourself here. What brought you here and what have you done since you got here? And we'll start with that one.
How did I get here? Wow, that was a long time ago, so I have to think about it. What I remember is I planned to come for 2 weeks and then 2 years and then go back to the Bay Area. That didn't happen. It's very hard to leave. Tokyo is so nice. So I was here on vacation 2018 and I liked the place so much. I realized that living in a big city was what was missing from my life in the Bay Area. As you might know, it doesn't really have big cities. California doesn't really have big cities like Asia does. The biggest city in the Bay Area is San Jose, and it's nothing like Tokyo. So I was here, I fell in love with the place, and 3 months later, I was moving here. I found a job at a robotics company, startup. So kind of the stars aligned. These were my 3 goals: to live in a big city, work at a very small robotics startup, work on self-driving. And that's what I did. I'm still here.
Okay, and then I know a little bit about you, but I don't know if everyone knows that your background actually, you worked a lot in Haskell and like these really strongly typed functional languages that are like very famous for being kind of obtuse and difficult. And then Rust is just so different from that. It has mutation, it has procedural code. How did you find yourself loving and using Rust? And what's your favorite feature of Rust? And what's your favorite thing that you miss from Haskell?
Wow, that's a great question. I'll try to time box this. I could talk about this stuff forever. So basically, I initially started programming in Pascal, and then my next language was assembly, and then C, C++. And I spent a lot of time programming C++ in programming competitions. It's just a great language for that. And then I somehow got caught up in this functional programming world of Haskell and then Scala, basically by mistake. So I needed to take an elective that said embedded programming in Haskell or something like that. And that looked exciting. I just wanted to do embedded programming, and I showed up. And the first, it was like a lab type of class, and the instructor said, "I'm really sorry, but the department didn't get the money for us to buy these embedded devices. So this class is just going to be Haskell." And it was too late for me to leave. And then I ended up liking Haskell a lot. It was very different in the beginning, and it twisted my brain in strange ways. But I came out alive, and I ended up liking this new way of thinking. And then when I started working in robotics and VR again, all of that had to be C++ for real-time constraints and so on. And I just couldn't go back to C++. I knew that you could just have a module system, like a real module system, not some mechanism that copy-pastes text. And tools that just work. You don't have to spend weeks learning them. And I was ranting to a friend about this, and he said to me, like, "There's this new thing called Rust. Maybe you should try it out." And I did, and I never looked back.
I guess the last one will be about Rust again, which is in the horizon of things coming in Rust. There's the potential stabilization of contracts. There's like a whole world of robotics applications happening now that people are talking about. And there's a bunch of stuff coming into the compiler eventually, like generic associated types, or I think those are stabilized, but generic associated constants and these kinds of things. What's your favorite thing that you're the most anticipating in unstable, or that's not even unstable yet?
Ooh, interesting question. If we're starting with just small things, if let guards in match expressions, I think they've been unstable for a while, and they were supposed to be stabilized. Maybe they already are. Those would already make me happy. Maybe they're already in. Another idea that I like a lot, and Rust, I feel like, is not the champion of this. The champion of the idea is Zig, is comp time. So doing more sort of evaluation at compile time. It's kind of constant folding on steroids type of thing. I really like that idea when I look at Zig examples, and I think it kind of meshes well with the philosophy of Rust. So I could seeing more of that in Rust would make me happy.
Well, we do have the crab time library, so there is that. And if you're watching this, Andrew Kelly, come convince us why Rust can't do it, and tell us, and come speak. We'd be happy to have you.
I would love to watch that talk.
Yeah. I'm sure Andrew considered Rust for his projects, and that's why he decided to make Zig. It'd be super interesting to have him, so come. Okay, that's it for me. Does anyone have any questions left about the talk itself that I rudely interrupted? Let's get from you. We haven't heard from you yet.
Yeah. Do you think the anodized spec can improve or make LLM so code generation of LLM, or have you observed the improvement of the code generation?
Good question. Big disclaimer. Anodized is still in heavy development, but I tried it on a couple of examples, and I think it works better than just comments because it's written, the expressions are written in Rust. So if I had to take a guess, that sort of robs the same part of the latent space inside the LLM that the code itself does. So it kind of just seems to work. It is kind of startling that Anodized has not really been long enough, has not really been around long enough for the training data to have picked it up. Like it's less than 6 months old at this point, but it just seems to work because it's mostly Rust. There's not a lot else in there.
Yeah, if more people use Anodized, maybe LLM is going to pick up the Anodized spec for their training data. That will, improve the outcome.
That's a good point. I'm hoping that would happen, and we're actually trying to make the documentation very meticulous and thorough for that to happen.
While I'm walking over, I'll ask a quick question. So you mentioned that like right now we just have like these runtime checks that you were showing. That's what it expands to. But what would it look like if something like Varus that uses, it's based on Z3, like so SMT solvers, like how would it consume anodized annotations?
That's a good question. Let's not start with Varus. I think there's more low-hanging fruit. So, for example, there's this other tool called Anodized that the way it works is it translates Rust code into Lean, and it does the verification in Lean. And they built their own infrastructure to consume Rust code that other tools can hook into. It's called Karen. And I haven't looked into this specifically, but my hope is that because Anodized just uses standard Rust, there's no extensions, and the proc macros are going to be in there when the source is parsed. There is probably a way to expose these Anodized specifications through Karen, and Karen is used by other tools, among them NES. So it's not unlikely that there's that's the path of least resistance to get this exposed to a heavyweight static analysis tool like Anodized. Even more low-hanging fruit, which I think we should try first, is just to generate property-based tests automatically based on these specs, because they're better understood and there's less complexity there. And I think that's entirely viable just by simple code transformation.
Awesome project. Keen to try it out. I was curious if there are any projects that have adopted Anodized yet that you're excited to see.
Not to my knowledge. Like I said, it's very young, but I definitely plan to use it more.
Cool. Maybe I'll be the first.
Thank you.
Not a question, but an experience report. At work, we have a drive macro which lets you annotate a struct with invariants, and it gives you a method called sanity check, which checks that if whether a specific value of that type meets the invariance, and then our fuzzers try to produce types which fail the sanity check. You said you were going to add this exact feature, right? I just want to encourage you to prioritize it because we make heavy use of this trait. It's really, really useful. Yeah, especially pairs well with the the pattern where you make an enum of your types API. So you have a variant for each of the methods, and then the fuzzer just generates a list of method calls and calls them, and then checks if the type is still sane at the end. This catches lots of bugs.
That's pretty cool. Yeah, let's definitely try doing that. I'm happy to help.
Does it work for const functions?
Great question. I don't know. That's one thing I have not tried. You get to be the first.
Yeah, thanks for the great talk. So my question is, I'm curious if it's possible to integrate Anodized with property-based testing frameworks to like enable a flag to let the like quick check or prop test to generate the tests based on the specification specified from Anodized.
Yes, I think that should be possible. It's kind of the low-hanging fruit. One thing to think about here, which is not trivial. So it seems easy, but in practice, it's probably not as easy as it seems. Is where were we? We're in the mystery function. There you go. So supposedly, the way this would work with a automatically generating property-based, some sort of property-based testing harness is just generate random instances of the input with something like the arbitrary trait, and then filter out the ones that fail the preconditions, and just feed the rest into the function and see if the post condition fails, right? So one problem with that might be that sometimes these properties might filter out most of the generated inputs. So if you're just blindly generating inputs, like for example, in this case, if you're just blindly generating arrays, it is very unlikely that they come out sorted. So your testing harness is going to be very, very inefficient. So there's probably a better way there where obviously in this case, it's just sort the input, but that's difficult to figure out from this spec for an automated tool. It's easy for us humans to see that. But once you get into more complicated properties, I think it might be not trivial to generate inputs efficiently that pass the precondition.
Yeah, we'll probably want to expand the spec to be able to reference user generatable distributions, like things that can give you a distribution, like a variable in distribution. And I actually have a fuzzer branch that I worked on all day today. And I brought the distribution combinator logic over, so you can, but even that's just kind of, it gives you a handful of out-of-the-box distributions, but obviously for your own data types, you're probably going to want your own distributions.
Yep, that's a great point. So Luke is one of the contributors to Anodized.
I just wanted to mention that fuzzers are really good at figuring out how to get inputs past these kind of checks. Like I think there was a paper where they put a panic at the end of Mario when you beat Bowser, and the fuzzer figured out how to beat Mario to get to the like as in what kind of inputs to type in the NES emulator.
That's amazing. I had no idea. Thanks for knowing that. Do you know what kind of tech those fuzzers use under the hood, like something like SMT solver, like Z3 or?
Well, I don't know about the Mario one, but normally they use, it's called coverage guided input generation. So they instrument the code to find out which functions they're actually are being executed. Yeah, I don't know, and then they randomly change them, and yeah, I'm not sure of the details.
So,
but they work really well.
What's the interface through which that such a generator interacts with the condition? Like, does it treat it as a black box, or does it have some sort of visibility into the structure?
So it's generating random inputs to a function, and it's trying to get the function to panic, basically. That's all. And then you do cargo fuzz, and it runs until it panics.
Gotcha. So it treats it as a black box.
Well, but the code is instrumented, so
right.
It can see what it's doing.
Is there a library that you know of off the top of your head that if we read the README we might have a better idea?
Yeah, cargo fuzz. Cargo fuzz.
Cargo fuzz, github.com/cargo fuzz, probably cargo fuzz twice. We'll see. We'll find it. Okay.
So I just remembered that there is some work in the actual Rust language to have a contracts feature. And I think maybe, was it me that sent it to you? I don't remember, but it was a while back. How different is that than this? Because I don't remember like how, I haven't been following that and I don't remember if I did. So is this like inspired by that? Is this like meant to be like a testing ground for something that could eventually be upstreamed into the actual language itself?
Yes. This is a testing ground, and it was also inspired by the coming contracts feature. And also, yes, you definitely sent it to me, and I remember I read it, and it made me excited. And I tried building a backend for Anodized that would just translate under the hood to the Rust native contracts, as they're called. And what happened is I very quickly started running into limitations. So for example, it's impossible to use multiple clauses of the same type in sequence, like you can't really stack them. And that's sort of a deal breaker because sure, you could just concatenate all the conditions together into like a giant and type of expression. But then you lose all the granularity of like, okay, which part of this expression is actually failing. So all you know is like, you got the spec violation and good luck. And I filed an issue on the project. And they said, yes, this is a known problem at the moment and they're working on it. I think progress on the native contracts is very slow. They don't have a lot of hands to work on it. And I believe it was actually not included in the Rust core team goals for this year. So it's kind of unfortunate. What we're hoping is that the work that we do on Anodized will actually help inform the UX decisions. So they can just look at Anodized and they can steal the best ideas and throw out everything that we figure out doesn't work. And we also plan to give people a one-click sort of migrate out tool in the end. When the Rust native contracts ship, you should be able to just run one tool that takes your Anodized spec annotated program and convert it into the Rust native one. And then hopefully we'll be able to just retire Anodized and move on to using the Rust native stuff.
That'd be super cool.
Thanks for sending the link again.
Anyone else? Going once? Ah, there we go. You always got to wait at least 7 seconds.
So I was wondering if you foresee this being used as some kind of, I don't know, runtime production hardening method, where you would say, I don't really, well, ensures they're good for like testing the implementation, but you could also use the requires to ensure that your invariant's not broken regardless, like if you're testing or in production. So did you foresee that kind of use case, or what do you think about that?
Yes, I think Anodized should ideally support all of these different use cases. So give people runtime testing when they want that, give people property-based testing when they want that, and give people heavyweight static analysis when they want that. Potential combination of these is, as you probably know, the best way to use these tools is in combination. If you're working in a safety critical domain, there's no such thing as too much testing and too much assurance, then your thing won't fail. And it often is the case, this is already kind of visible, that you can cover a lot of ground with just a type system. You can express useful things. And you can often get the last sort of 10, 20% by just strategically chosen unit tests. Often the types already constrain the implementation space so narrowly that you can weed out the non-compliant programs with a couple of unit tests. But sometimes you do need property-based testing, and sometimes you need to go all the way to formal verification, and all of these should be supported.
Often when something like this gets called, the input you might only call this version of the function if the input is specifically in this way. But the knowledge of the fact that like this was the right way to call it is kind of duplicated. Like, it might be interesting if the spec can generate a function that returns a data type that tells you how many of your requirements have actually been satisfied, and then you can actually like pattern match on that and decide on which function to be called, for example.
Hey, that's an interesting idea. So it's kind of, it feels related to this concept of a witness. When you want to show that your function fulfills some property, then you have to construct a piece of data that can be traced back or that can be run through a checker. So it's, I guess an example here that we have at hand is this sorting business. So instead of doing this multi-set stuff to express that the output and the input have to contain the same elements, another way we could have written this is we could basically say that instead of producing the sorted array, the output must be a permutation. So it's going to be like use size stuff, right? And then it's easy to check that something is a permutation. And then that some other function, I believe this is what you're saying, could check that, okay, this is a permutation, and then apply it to the output. And then the permutation is this kind of the witness that shows you once you apply the permutation, that output will contain the same elements as the input without doing this complicated business. But then that kind of changes the signature of the function. It makes it more testable or checkable in a way. Is this in line with what you were asking?
This is interesting and related, but not quite the same. I was actually thinking of it in terms of the requires. So like the requires says like, you've met all requirements, you can call this function, right? Whereas what you're describing is kind of the dual of it, which is we're giving you something that you will be able to use to, call the thing you wanted to call. So related, but different.
Gotcha. Can you maybe think of an example? All right.
I feel like we're starting to implement Erlang.
Exactly. This is, I think it's related to Erlang and guard clauses in function definitions. So it is gonna dynamic dispatch based on guard clauses, like applying to the function inputs. So in that regard, that might be interesting to look at this in that sense. But in Rust, we definitely, like, not often you see stuff like this in Rust when you have like, you have like 15 function definitions and all differ for the type of input you're getting. Like, it might not work really well with the type system.
Just so I understand it correctly, would it be something like basically dynamic dispatch where you say, okay, if this the input has length 2, or like the input is shorter than some threshold, then we're just gonna do, I don't know, insertion sort. And if it's large enough, then we're gonna switch to squeak sort.
Yeah, something like that.
Gotcha.
Yeah, for sorting, from the top of my head, I can imagine that starting from some size, we can just switch to some vectorized implementation or something like that, because now it's solved by explicit checks, but this can be automated.
Interesting. That idea feels somewhat orthogonal to, trying to convince yourself or a third party that your program is correct.
Okay. So I just, after this one, I'm gonna cut off because I want to give us some time to mingle before and like all chat. And I have one more announcement after this, and then I'll let everyone chat.
Yes,
and mingle.
instead of having this this serializing bottleneck, we could have these conversations in parallel. It's completely async, distributed.
A bit of a maybe stupid question near the end. I was curious, like, if you could assert something like doesn't allocate more than some amount of memory, or maybe even like is idempotent. So if you run it twice, it produces the same stuff. Something like that. So are those things possible? Is it even like the wrong kind of system? Is it like functional? That's like something on that.
It is definitely not the wrong kind of idea. Like if these questions appear in your mind, somebody surely has these as actual use cases where they need to be convinced that their function won't allocate. In fact, in a lot of safety critical domains, it's a thing that you have to allocate all your memory up front and then you know dynamic stuff. It's difficult to implement. It's kind of related to Brendan's question about side effects. Like allocation is a type of side effect, right? Or panicking is a type of, non-termination is a type of side effect, a very nasty one. And I think there's some hope that once we allow the spec annotation to be placed on an entire module, you can express these sort of complicated relationships that I don't remember now, but you mentioned something else after allocation, idempotency. So for example, idempotency, you can express as a module level property, as Alex was saying, by saying that these sort of sequences, if you execute this sequence, the result is going to be identical to this other sequence where it's only called once. That's a good example. Side effects, I'm not sure. Sort of, it's an interesting question, right? Like a lot of languages like Haskell or newer languages, Idris, they encode side effects specifically into the type system as effects. And that's very powerful, and Rust doesn't have any of that. So it's ideally, I think that would be added to the Rust type system itself, because it's very difficult to express something in like a proc macro. It sounds kind of insane. And also another related thought there is that a new wave of verification tools was enabled by Rust. There were older systems that all had the same problem of essentially having to deal with aliasing. Like when you have to deal with aliasing, when you're under the hood, you don't know if two pointers are in fact point to the same memory location. That causes big problems when you're trying to prove stuff. So a lot of these older systems kind of were banging against this wall. And when Rust came out, they realized that, hey, we can just move whatever infrastructure we've already developed to be on top of Rust, and then this problem just goes away. So a lot of these systems have like direct lineage back through tools that were not using Rust, but now they are. So like Varus used to be Daphne, that was either for C# or C++, I don't remember. So there's this direct lineage, right? And I think that's just an example to say that often small improvements in type systems just enable much, much better tools.
I know what you're thinking, Andrew, because you're watching this. If you just passed your allocators everywhere, then we could just use an allocator and do it. Well, come and convince us, and then we'll change Rust. Okay. So I really want Andrew Kelly to come visit Tokyo, obviously. Just really quick, if you could pull up tokyarust.org for me. I just wanted to reiterate one more time, and I'll say it in Japanese too, just in case We would love more speakers. Anodized is an open source project, and we are open to contribution. Máté is open to contribution. So if you have some of these ideas and you're willing, you think you might find some use in Anodized, but if it only had this one thing, please open an issue, contribute, reach out. Same thing for Tokyo Rust. This is our website, tokyarust.org. If you have a project that you've worked on in Rust that you think is cool, you can really easily with a script or with a simple pull request add it to the website. It's on GitHub. There's a link to the GitHub on it. I implemented Shizen and Sarect. Those are me. Unifont. I don't know who did that, actually. Since I last looked, there's a bunch more. PathMap is a great project by Luke, who's also contributed to Anodized. Like, all these are just our projects just to show off to one another and get inspiration. So please feel free to do that. And also, we are a not-for-profit organization. So if you have some money just lying around, we could use it. Bigger events, more space, more drinks, more pizza, better speakers. I mean, Máté's a great speaker, but more speakers. And if your company has space that they'd like to be willing to let us use, it's not fair to Google for Startups or to people who aren't in this area to always have it in the same place. So we'd love to be hosted, and we'd also love for them to donate. And we have a donations page that we can show them, and we could also showcase them in these talks, and we could also negotiate other things they might want, such as helping with recruiting or things like this. So let them know. And then 簡単に言うと、こういうイベントを開催できるスペースを探してて、あと交付も大募集中ですので、会社か自分からの寄付があれば、ぜひ寄付してください。スペースかお金、どっちでもお願いしたいですが、それ以外、このプロジェクトのページもあって、自分が開発したことを投稿したかったら、ぜひ、tokyarust.org のプロジェクトページの PR を開いて、提供してください。お願いします。どうぞよろしくお願いします。はい、以上で、Let's mingle。混ざり合いましょう。